Thank you for joining in. This project is funded by the European Union Horizon program. Our webinar series is a part of the Circuits project and EU Green Week 2025. Please enjoy.
Okay, hello everyone. I'm Cristian Trisolini from SUPSI. I'm a researcher at SUPSI that I'm involved in the development of the GRETA tool. So now I will quickly present you GRETA tool. So GRETA is a web application developed to assess the sustainability and circularity performances of products and processes in the manufacturing context. It offers diagnostic and advisory functionalities, enabling users to optimize their manufacturing practices and make data-driven decisions. So GRETA aims to fill the gaps of existing tools, improving their effectiveness and usability, promoting a more comprehensive and integrated approach toward a more sustainable decision-making. So GRETA is a proprietary software owned by SUPSI, along with an integrated methodology that has been tailored to meet the unique demands of a manufacturing company focused on sustainable early-stage product design. This tool empowers users to generate and contrast various product manufacturing and user scenarios, leveraging the limited data typically available during the preliminary stages of product design. In response, the software delivers insightful sustainability profiles, harmonizing environmental, economic, social, and circular aspects. This helps users identify the most eco-friendly and cost-effective option. So I will now go through most of the feature offered by GRETA. First of all, it can evaluate 4 different assessments. Life cycle assessments, which evaluates the environmental impacts of products and processes. Life cycle cost evaluates the cost. Social LCA evaluates the social sustainability aspects, and circular economy evaluates the circularity of a product. All of these leverage on a specific inventory database. For example, for life cycle assessment, we leverage on EcoInvent. GRETA can compare the sustainability aspect of 2 or more different products in real time. This allows the user to experiment on different product alternatives. It also integrates advisory features that provide users with additional insights into the results and guidance on how to improve them based on the model which has been developed. It also supports the bill of material standard and evaluates the impact of each component, showing how much each component contributes on the overall product footprint. It can easily integrate with real production environments via remote services, but it can also integrate with legacy systems. The platform offers authenticated REST APIs, web services that allow third-party applications to interact with GRETA. And lastly, GRETA ensures data isolation with a multi-domain solution. Okay, now to give you a closer look at how this works in practice, I'll hand it over to my colleague Simone, who will walk you through the live demo.
Yes, thank you, Cristian. Hello, everyone. I'm Simone. I'm a research assistant in SUPSI, and I'm involved in a Circ-uits project. So this is the model that we developed to assess the continental device, one pilot within the Circ-uits project. We structured this model as a bill of material, as you can see here on the left, and this represents a distinctive feature of GRETA. The model includes all the components that constitute the device, from tick seal, battery, cage, cap, and go on, enabling a thorough evaluation of three key aspects: life cycle assessment, life cycle costing, and social life cycle assessment. This capability to assess the entire product life cycle is another strength of GRETA. For each component, we have focused on two main life cycle phases: the raw material extraction and the manufacturing phase. And for the final product, we also include three additional phases: assembly phase, reuse phase, and end of life phase. For each phase, we define specific parameters to allow various product configuration. GRETA enables the creation of different parameters to model multiple scenarios and then to model different device concepts. These parameters allow to modify the device configuration and evaluating it under different conditions. For example, let's take the negative contact. Here it will be possible to adjust the weight of the component, the percentage of the material, in this case chromium, iron, nickel, and the number of negative contact in the cage, which is set to 1 in this model. And for the assembly phase, instead, for the assembly phase, we modeled this phase using two parameters: the energy consumed during the process and the cost of that energy. And we also included an alternative flow, which let us define the type of energy used. By default is global, but we can change this energy in Chinese energy, European energy, or American energy. For the reuse, the model gives you the option to consider it or not. If you decide to include the reuse in the model, you can choose between three different scenarios. In the first scenarios, the entire product is replaced. In the second scenario, only selected components are replaced. You choose which one and how many times each component is replaced. And in the third scenario, you define the expected lifespan of the product, and based on that, the model automatically calculates how many times each component needs to be replaced to meet that lifespan. Now, if we launch the assessment, we obtain the result for the LCA, LCC, and social LCA. Starting with the life cycle assessment, the bar chart here clearly illustrates that the raw material extraction phase has the most significant environmental impact among all life cycle phases. Additionally, we can delve deeper to identify the specific component that contribute the most in each phase, thanks to the bill of material representation. For instance, if I scroll down, under the first of all, you have to choose the impact category that you want to analyze. For example, in this case, climate change. And if I scroll down here, the component with the highest impact are the PCB and the valve stem. This type of analysis can be repeated for all other phases and indicator as well. Furthermore, we can focus to a specific life cycle phase to underline which component had the greatest impact. For example, if I want to analyze the manufacturing phase, here I have again to choose the impact category that I want to analyze, for example, climate change. And if I look at the impact of the component related to this specific phase, I can see that again the most component that the component that have the higher impact are again the PCB and the valve stem and also you can break down this component and look at the process that we use to model this component. Furthermore, we have the life cycle costing. The cost for each component are currently based on estimated value for manufacturing, assembly, energy, and end-of-life processes. The chart here illustrates the cost assessed for each life cycle phase. In this case, the highest costs are related to the manufacturing phase. Additionally, the model provides the social life cycle assessment, presenting results based on all the indicators included in the SOCA methodology, as depicted in this bar chart. Once again, we can identify hotspot throughout the contribution tree. And now, one key feature of GRETA is its ability to compare different scenario templates. For example, if we create two different scenarios, so now I'm creating two different scenario templates, so two different scenario of product. We can compare two different scenarios. At the beginning, we can see that the scenarios are the same because the scenarios have the same value. But if, for example, if I change the value of the valve steam, that was the component that we identified before as the most significant impact. For example, I change the composition of the material inside the valve steam, and I put, for example, 14 for the brass, 10 for the lead, and 50 for the nickel. We can observe that the second scenario performed better across 25 impact indicators. However, if we also adjust the component weight, for example, here in the second scenario, we can see now that the first scenario now is better because 20 out of 25 indicators are better in this scenario. So this capability allows GRETA to effectively compare any scenario you wish to assess, providing a comprehensive view of potential design optimization. That is all from my side. I don't know if there are questions, or otherwise I leave the floor to Paolo or Bernd.
Thank you for watching this webinar episode. If you're as passionate about sustainability and innovation as we are, here's how you can get involved. Stay connected with us on our social media and website for the latest updates and insights from the Circ-uits project. Whether you're an individual or an organization, there are plenty of ways to contribute. Reach out to us to learn more about partnership opportunities, events, and initiatives.